Okay, we're going to be looking at today doing the unit circle in your head. So in your notes, I had a whole bunch of information of things that I explained a little bit yesterday and things that I'm going to go over again today. So this part of your notes up here is explaining what we talked about yesterday with the reference angles. Okay, so there's two things that one I want to remind you of, and then one that's new. So let's look at this one first. You have this represents which functions are positive in the quadrants. So all of your functions, so sine, cosine, and tangent, are all positive in the first quadrant. Your sine is positive in the second quadrant, your tangent's positive in the third quadrant, and your cosine's positive in the fourth quadrant. Everything else is negative that's not listed in these ones. Okay? So you can remember this by thinking all students take calculus, or you can do all students take choir, or make up anything of your own that works for you. So another way that you could do the unit circle is I could find out the quadrant it's in and just remember the point and then decide if it's positive or negative based on this piece of information here, rather than getting the point from negative and positive. So it's kind of similar. The one that I like to use the most is with the tangent, because the tangent you have to take both your y value and your x value to get the sign, like positive, negative sign. So I like to use this for the tangent, but for sine and cosine I like to just kind of visualize, well, I went left, that's your cosine, so it's negative. I went down, that's your, on the cosine, or on the y value, that's going to be negative. So I kind of like to remember it that way, but whatever works for you is perfectly acceptable. So the thing that you need to remember when you're doing the unit circle just out of your head, some way you need to remember that anything pi thirds is going to have a reference angle of pi thirds, which equates to 60 degrees, and 60 degrees, your point's 1/2 root 3 over 2. Anything pi 6 has a reference angle of pi 6, which is going to be a reference angle of 30 degrees, which is going to be your point root 3 over 2, 1/2. And then anything pi fourths, forgot pi, is a reference angle of pi fourths, which equates to 45 degrees, which is going to be your point root 2 over 2, root 2 over 2. So the way that I kind of like to remember this, like I told you before, the 6 and the 3 switch on your, from the radians to the degree reference angle. And then as far as remembering the point, since this starts with a 3, the point starts with a 3. Okay? And then on these ones, for the 45, these match and these match. So then the way that I remember the 60 degree reference angle is the fact that it's 60, so it doesn't start with root 3, so then it has to start with 1. That's kind of how I like to go about remembering this. Okay, and then if anything's on the axes, like 90 or pi halves or 3 pi halves or 270 or pi or 2 pi or 180 or 360, I like to just draw where it is on the quadrant and then write my point out and then find it from my point that way. So I suggest that you work on memorizing this in some way, whatever works for you. If you would just want to straight up memorize it, if you want to use the fact that pi thirds would go to 60 degrees, pi 6 would go to 30 degrees, pi fourths would go to 45 degrees, 45 degrees match, it's like the odd man out, the point matches, 30 degrees goes with root 3. However you want to do it is fine, but you need to find something that works for you to remember that. Okay? So let me show you the process that I go through on how to find the unit circle, or just off of my head, the points of the unit circle. So I figure out which quadrant it's in, I find the reference angle, I remember the point that goes with the reference angle, I adjust the signs based on which quadrant it's in, or I use the all students take calculus, and then I find the trig value. Okay? So, and this also makes you have to remember that the sine is the y value, the cosine is the x value, and the tangent is the y over the x value. And remember, our shortcut for the tangent is to take the top of the y over the top of the x and simplify it that way. So I'm going to walk you through how I do this when I'm doing it in my head. Okay. So for the sine of 150, the first thing I think is it's in the second quadrant and I have 30 degrees as my reference angle. Well, 30 degrees starts with root 3, right? Oh, go up higher. 30 degrees, root 3. So my point is root 3 over 2, 1/2. Okay? And so then the sine is the y value. I fix my signs, like the positive, negative signs, according to the quadrant. So the x is left, which is negative, and the y is up, which is positive. So then I pick the y value, which is 1/2, and it's positive. The other way you could do it is this is all students take calculus. So the students stands for the sine, so the sine is positive in this quadrant, so I would have a positive value. Okay. For the cosine of 60, 60 degrees has a reference angle of 60. It's in the first quadrant. 60 degrees doesn't start with root 3 because it's not 30. So then I start with 1/2 root 3 over 2. So the cosine is the x value because why sin? Because it's extra fun. So I take the x value, which is x equals 1/2. Oh, I don't really need to write x equals. It's in the first quadrant, so both of these are positive. Or you could do all students take calculus, so all of the trig functions are positive in the first quadrant. The tangent of 210, the first thing I think for 210 is it has a reference angle of 30 degrees. For the degrees in the third quadrant, I just memorized one of them. I memorized 240 was 60 degrees, so 240 is not 210, so then it has to be 30 degrees because 45 ends in a 5. Remember that all of your degrees, your reference angle with 45 degrees will always end in a 5. So your 135, your 225, and your 315 end in a 5, so, and 45 obviously, have a reference angle of 45 degrees. So that way you can remember quickly what this reference angle is. So my reference angle is 30 degrees. So I'm in this quadrant. 30 degrees goes with the point root 3 over 2, 1/2. I'm in the third quadrant, so both are negative. The tangent's the top of the y, so I take the -1 over the top of the x, which is negative root 3. Now, negative over negative turns to positive. I ran out of room, so I'm going to simplify up here. So you have 1 over root 3. But remember, you have to rationalize, so I need to multiply by root 3 over root 3. It may be beneficial for you to remember that 1 over root 3 is the same thing as 1 times root 3, which is root 3, over root 3 times root 3, which is just 3. So 1 over root 3 is the same thing as root 3 over 3. One is rationalized, one is not. Okay? So this turns into root 3 over 3. The other way that you could tell the sign, like positive, negative sign, is that I have all students take calculus. So since this is the tangent in the third quadrant, it's going to be positive. So you can either worry about the sign by doing all students take calculus, or you could label your point. You don't have to do both. I'm showing you both. Okay. Our last one, the sine of, or in degrees, our last one. The sine of 180. 180 is on your axis, so I'd just like to draw it out like that and put a dot where it is. And it's -1, 0. Okay. The sine is the y value, so the y value is 0. Okay. For radians, it's really fast to see what your reference angle is because of the fact that anything pi fourths is going to be a pi fourths reference angle, anything pi 6 is going to be a pi 6 reference angle, anything pi thirds is going to be a pi thirds reference angle. So finding the reference angle for radians is actually faster than degrees, I feel. So 3 pi fourths is just a little bit before pi. So to figure out which quadrant it's in, I say how many times does 4 go into 3? It doesn't go into it. It's almost 1, right? So I'm just shy of 1 pi. So just shy of right here, so it's going to be right here. 3 pi fourths. Fourths goes with 45 degrees. 45 degrees is the point that matches. The point that matches is root 2 over 2, root 2 over 2. I'm in the second quadrant, so the x is negative, but the y is positive. The sign is the y value, so I pick root 2 over 2. Or you could say all students take calculus. S stands for sine, so the sine is the y value and the sign is positive. Okay? For the cosine of 5 pi 6, 5 pi 6 has a reference angle of pi 6, so it goes to 30 degrees because the 6 and the 3 swap between radians and degrees. So the point with 30 degrees starts with root 3 over 2, then 1/2. The cosine is the x value. The x value is root 3 over 2. Now I didn't figure out the value, the positive or negative value of it. 5 pi 6, if I go up by 1, I would get 6 pi 6, which would put me at just 1. Or how many times does 6 go into 5? Almost 1. So I'd be just shy right here. Or just shy of pi right here. So then I have all students take calculus. So notice the sign here is positive. I'm finding the cosine, so that means that this one is going to have to be negative. Or you could think to yourself, I went left, so the x value is going to be negative. Either way is acceptable. Tangent of 2 pi thirds. I think to myself, pi thirds, so it switches for the degree reference angle to a 6, so it's 60. 60 doesn't start with a 3, so it starts with the 1/2 root 3 over 2. The tangent is the top of the y over the top of the x. That's our shortcut. So I'm going to take root 3 over 1, which is just root 3. I didn't find the positive negative value. 2 pi thirds. Notice 3 goes into 2 almost once, right? If I have one more, so I'm just shy. I didn't mean to put all of these in the second quadrant. Sorry about that. It's just shy of 1 pi, so I'm in this quadrant. Notice all students take calculus. Notice this is sine in the second quadrant is positive, so everything else is negative, so the tangent is going to be negative. Or your x value is negative and your y value is positive, so I would have a positive over a negative, which would simplify to a negative. Okay. Our last one is tangent of pi halves. Pi halves is on your axes. It's either straight up or straight down, and then your even or an odd pies are left or right. All your even pies are to the right. I don't know which direction that is that shows up on the camera. To the right. And then the odd pies are to the left, whichever direction that is on the camera. That's my left, so maybe that's yours, I don't know. So the tangent of pi halves is straight up. So remember we counted by halves. This was 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, right? This is the same thing as 1/2 pi, right? So we were always counting by 0.5 pi, 1 pi, 1.5 pi, 2 pi, right? And kept going around. So pi halves is right here. So my point is I didn't go left or right at all. I just went up by the radius of 1, because remember the unit circle has a length of 1. The tangent is going to be the top of the y over the top of the x. In this case, we don't have a fraction, so it's just going to be y over x. So I'm going to have 1 over 0. But what do we write 1 over 0 as? It's undefined. Now, if I had 0 over 1, that's 0, right? If I had 0 pieces of a pie that was split into 1, that means I have 0. But if you're trying to divide by 0, like cut a piece of pie into 0 pieces, that doesn't make sense, so we call it undefined. Okay? And that's how you do it in your head. There was something else I wanted to tell you about the radians in the quadrants. So if you look here in the second quadrant, I neglected to mention this yesterday, but if you look at your radians right here, notice that all of these, the numerator or top is 1 above, or 1 below, sorry, the denominator. So 5 is 1 before 6, 3 is 1 before 4, 2 is 1 before 3. That stays true for anything in the second quadrant because it's just shy of 1 is what that means. In the third quadrant, notice that it's 1 above. So 7 is 1 above 6, 5 is 1 above 4, 4 is 1 above 3. So that's going to be just a little bit more than 1 pi. So that's why it's in the third quadrant. In the fourth quadrant, it's 1 before double. So if I double 6, I get 12. 1 before that is 11. If I double 4, I get 8, one before that is 7. If I double 3, I get 6, one before that is 5. Now remember, this is 2 pi, so if I wanted to write 2 pi with a common denominator of these, I would double the bottom, and that would give you 2 pi. So it's just shy of 2 pi. So that's kind of how I remember where the quadrants are. Kind of the same idea with the coterminal angles that we talked about. Is it closer to pi, or an even pi? An even pi is over here, or an odd pi over there. Okay, so that's something that can help you out with your radians and figuring out your radians. Also remember that any of your 45 degrees ends in 5. Okay, so let's see how you do on your homework assignment.